Hi, I'm Alex and welcome to another episode of Almost Everything on Almost Anything. Each week I pick a topic I know a little bit about and we learn about it together. Today we're zooming out from ancient Rome to something a little bit bigger. We're going to be looking at our galaxy, the one we call the Milky Way. Have you ever wondered why it is shaped the way it is, how it was formed, and where exactly are we inside it? Today, we're going to break down what the Milky Way is, why it looks the way it does, and how scientists figured it all out while being stuck inside a tiny little planet on the outer suburbs of it. The Milky Way is one of those things that you learn about in school or see in documentaries, but for something that contains everything we've ever experienced, I realized I actually knew next to nothing about it. Like, how old is the Milky Way? What's actually at the center of it? Why is it a spiral? And how do we even know any of this if we've never seen it from the outside? So today, I wanted to finally wrap my head around the very thing we exist inside of, the Milky Way galaxy. There were four main things I wanted to figure out. How the Milky Way actually formed, what it's made of and how big it really is, where exactly our sun and Earth sit inside the galaxy, and lastly, how scientists managed to work this all out in the first place. Because when you think about it, we're trying to describe a building that we've never walked around. We're inside it, stuck on one floor looking at the ceiling. So let's break this behemoth down. The Milky Way is what's known as a barred spiral galaxy. Imagine a giant pinwheel, but with a bright glowing bar running straight through the middle of it, like a neon baton that someone stuck through the center of it. And inside this galaxy, we have 100 and 400 billion stars, at least 100 billion planets, nebulae, dead stars, baby stars, and collapsing stars. We also have stellar nurseries where new stars are being born, and black holes, literally thousands of them. It's quite old too, around 13.6 billion years old. That means the galaxy formed not long after the Big Bang itself. But here's the scale that will really wig you out. If you got in a spaceship and flew at the speed of light, which is about 300,000 kilometers per second, it would still take you over 100,000 years to cross from one side of the galaxy to the other. And we, the Earth, Sun, Saturn, and everything, sit in one of the quieter neighborhoods of the galaxy called the Orion Spur, which branches off the largest Sagittarius arm. It's not too close to the chaotic city center, but not out in the empty bushland either. Kind of like being in Castle Hill instead of Surrey Hills. You're close enough to see the lights, but you're far enough away to avoid the chaos. The Milky Way didn't appear fully formed when the Big Bang happened. It grew, and it honestly grew pretty violently. Here's the current best theories of how our galaxy built itself. In the early universe, everything was gas, mainly hydrogen and helium, but there were tiny fluctuations and slightly denser patches. Gravity pulled those patches together, and one of those just happened to become the seed of the Milky Way. These early stars were huge, way bigger than our sun, and burned extremely bright and fast. They lived short yet chaotic lives before exploding as supernovae, pumping heavier elements into space. These explosions helped create the building blocks for future stars, planets, and eventually life. This bit was the wildest part to me. Over billions of years, the Milky Way collided with and absorbed smaller galaxies. And it's still doing this today. There are giant stellar streams around us, long ribbons of stars that are literally the remains of galaxies that we've swallowed. One of the most famous is the Sagittarius dwarf galaxy, which is currently being torn apart and added into the Milky Way. The spiral arms aren't fixed structures. They're more like slow motion traffic jams. Stars move in and out of them, but because of the galaxy's rotation, the arms stay in a spiral shape. It's a density wave that travels through the galaxy like ripples in a pond. So the Milky Way isn't static. It's alive, constantly reshaping, evolving, merging, and spinning. At the heart of the galaxy sits something a little bit scary. It's a supermassive black hole called Sagittarius A. This thing is about 4 million times the mass of our sun. Now, it's not sucking everything in like a big vacuum. Instead, everything in the galaxy, including our sun, is orbiting around it. But the center is not somewhere you'd want to be. It has intense radiation, stars packed insanely close together, constant supernova explosions, gas clouds smashing into each other, and gravity so strong it warps space. It's basically King's Cross on a Saturday night, about 15 years ago. Loud, chaotic, and absolutely not a place to raise a family. Life formed in the outer suburbs for a reason. Out here, things are calmer, quieter, and a little bit more stable. So where does Earth sit in this little galaxy of ours? We're not in the middle, we're kind of nowhere near it. The Earth sits about 26,000 light years from the center, roughly halfway between the core and the outer edge. And everything is moving. The Earth, along with the rest of our solar system, orbits the center of the galaxy at about 230 kilometers per second, fast enough to get from Sydney to Perth in about under 20 seconds. And even at that speed, a full orbit, which is 1 galactic year, could take anywhere between 225 to 250 billion years. To put that into perspective, when dinosaurs first appeared, we were in a completely different part of the galaxy. Humans have existed for less than 0.1% of one orbit, and your entire life, not even 0.0000003% of one lap. It's insane how tiny we are on this scale. We've never seen the Milky Way from the outside, yet we've mapped it, measured it, and modelled it like never before. And here's how we've done it. Satellites like Gaia track the positions, brightness, and movement of over 1 billion stars. This lets us map the galaxy in a 3D model. Dust blocks visible light but not infrared. Instruments like the Spitzer telescope lets us see into the core. Now, radio telescopes reveal gas clouds, star-forming regions, and the movement of the spiral arms of the galaxy. By measuring how fast different parts of the galaxy rotate, scientists can work out the shape, mass, and structure of it. This rotation also gives us one of the biggest clues in modern physics. The Milky Way is spinning way too fast to be held together by matter that we can see. There must be this extra invisible mass, which is actually called dark matter. Dark matter makes up most of the galaxy, and without it, the Milky Way would just fly apart. We look at other spiral galaxies in the universe and use them as reference points. It's like trying to understand your own house by looking at your neighbour's roof because you can't see your own. Together, these tools gave us the best possible picture of something we can't step outside of. The Milky Way won't stay like this forever. In about 4 to 5 billion years, the Milky Way will collide with the Andromeda Galaxy, which is another massive spiral-armed galaxy just like ours. This galaxy is heading straight for us, but don't imagine star-on-star carnage. Space is mostly empty, so most of the stars will pass right by each other. Gravity will pull the galaxies together, twist them, and eventually combine them into one giant supergalaxy. Scientists have already come up with a name for them, either Milkometer or Milkdrometer, which honestly sounds like a dodgy yogurt from Aldi. Either way, the night sky will look insane. It'll be two galaxies merging into one giant structure, which in my opinion will kind of look pretty hectic. Learning about the Milky Way has made me realise just how small and insignificant we really are, but in a good way, I promise. We're living on a rock, orbiting an average star, tucked away in one of the quiet suburbs of the galaxy that's been around for 13 billion years. Yet humans have somehow managed to figure out how it all works. We've mapped an entire galaxy we can't even step outside of. We've uncovered dark matter without ever really seeing it. And we've worked out our place in the universe using nothing but physics, some telescopes, and a little bit of curiosity. This is a reminder that curiosity isn't a personality trait, it's something very, very powerful. It's something that can map an entire galaxy. So that, my friends, is the Milky Way. Our home that is full of billions of stars, an enormous black hole, and a future collision with another galaxy on the horizon. Thanks for being here today. Please like and subscribe if you enjoyed the video, and I'll see you next week where we'll get the chance to learn about another topic. Bye for now.